A here, okay, is subject to be recorded, okay? Everybody clear? Okay, good. So what we would like to know here, once again, how much this area is, right? Has anybody figured it out yet? Anybody? Yes, please figure it out. Okay. So again, our question is what? Our question is that we have an, yes, go ahead. 15.87. Very good, 15.87. Very nice, very nice. Okay, so is 15.87. Everybody agrees with Patrick here? Okay, very good. So the way to do is what? We go to very good. Yeah, we can go to table A, right? But here I'm just using the calculator, right? So I'm computing this cumulative area, right? So when I choose this option, what do I do here? I put the lower limit first, right? Is everybody fine on this? Okay. Who is the lower limit? How low can the contents will be? How low? Louder. 4.8. 4.8 is right here. See, there are bottles with lower contents even than that, Patrick, right? Okay. So anybody? Okay. Well, let's say, let's write a realistic figure first, okay? That the lowest it can go is how much? 0, right? Makes sense? Okay. Or louder? Somebody asked me a question. Okay, nobody asked me a question. That's all right. Okay. And how high do we want it to go? Up to 5, right? Everybody clear? So how do we do here? We write the lower number, the upper number for the region that we want, and then we enter what? The parameters, right? Everybody clear? Okay. So what are the parameters here? The mean and the standard deviation, and we have to enter that in that particular order, okay? And you shall see that Patrick is correct, that we have what? You said 15 point, you know. Right, exactly.
How did you, oh wow, that's pretty, yeah, how did you get that normal?
Okay, you do this. You see, we are looking at normal distribution, right? Yep. Here is distribution, and mine is coded blue. So I just went blue and then this key, and then takes me to the,
What's normal PDF?
A normal PDF, it will give you a value for just, you know, tiny around for a particular value. In this particular course, you are not using it, okay? All right. Everybody clear?
In which order did you say to put it?
Okay, I'm going to write it for you, Ron. Just give me a second. I'll write it for you. Which order, okay? All right, very good question. Oops. Thank you, sir. Okay. So the order that we write it in is this. See, norm, CDF, right? The lower limit of the area, whichever area you want to compute, then the upper limit, all right? And then what you write? The mean, and then you write the standard deviation, okay? Answers the question? And it has to be in that order, okay? All right, I'll explain you why, because of the just the calculation method or algorithm that this calculator follows, okay? Everybody in the room fine? Good. So do you think it's kind of, you know, if we are talking about a medication, right? So if this medication is dispensed with like thousands of people and about 16% of it is underfilled, you know, then what the label says, you know, that's a problem, isn't it, right? And 16% is a good percentage, right? Everybody clear? Okay. So that's why you need, that's why Dr. Zhao wants us to do chapter 11, okay? All right, and we are going to go into chapter 11 in this context, okay? Okay, good. All right. Now say, okay, to find the probability, okay, that the mean of the contents, okay, of a simple random sample of 4 bottles from the above population, and they are making hundreds and thousands of bottles like that, okay? All right, from the above population is less than how much? 5 ml. All right, everybody clear? So what will happen? Say I went ahead and I got a package of 4. I may have a different mean, right? Somebody else goes, they will have a different mean. Let me just show you how this how this varies. Everybody clear? Okay, so I'm going to do a simulation for you. All right, and if you want to have fun with this simulation, the package that I'm using for this, it's available in our Math Science Center, okay, next door, in case you want to. Does Dr. Zhao require this? I don't require it. I don't know whether she does. Okay, good. So see, what I'm going to do here is that I am going to simulate for you, 1,000 bottles, all right? Sorry, 1,000 packages, not the bottles. 1,000 packages of size how many bottles in each? 4. All right, everybody clear? From this population, so we are going to see this. So this is what we have here, and I'm going to enlarge it, so just be patient for a second. Okay, bottle 1, here is bottle 2, all right, excuse me, bottle 3, and then I have a bottle 4, okay? All right, now let me just take it to a little friendlier situation, okay? And that is in, because all of you know how to use Excel, right? Okay, all right, excuse me, just a second, it did not copy, and I lost my software. Where did it go? Okay, here it is, right? Copy, go to Excel, please paste it, here it is. All right, okay, and I'm going to enlarge it so that we can all see, all right, because the projector has, like, the bulb needs to be changed, right? Okay, so here we are, right? Everybody good? Okay. Very good. So just a second, let me just make this the same size. All right, okay. So here I am writing the sample means. Everybody fine? So what we have is, this is a simple random sample of 4 bottles from that population, right? Everybody good? Okay. Yeah, is that making sense? Good, thank you. Okay, so if I want the mean of this sample, okay, see, in Excel you can do it directly like this. Just go to insert function, and what do I want? Average, right? Everybody clear? And if it doesn't show average to you directly, just go to statistical. All right, so what are the average contents in the first sample of the 4 bottles? 5.12, right? Everybody clear? And here are all these guys, okay? In the second one, how much it is? You can 5.31. Do you see any going below 5 in this list so far? Do you think it will never happen? It will probably happen. Very good. Let's see if it happened. Oh yeah, right here. There is one, right? Makes sense? You know, it happened here, right? Everybody clear? But it will, we expect it to happen what? Little less often, right? Okay. So what happens is this, that I'm going to do this, okay? That is, one sec. Values. All right. And here we are, right? Now I'm going to go ahead and sort this, okay? So when I sort, just to see that how many of them have a contents of what less than 5 milliliters, right? Everybody clear? So I'm going to sort this guy. So sort it from smallest to largest. No, don't mess anything else up, right? So you can see how many bottles did we have? Tell me how many? I think how many samples did I have? Sorry, 1,000, right? Everybody clear? And out of those 1,000, we have, okay, these many. How many? There's like 27. Top is the label. About 26 out of 1,000 went in that area, right? Everybody clear? Okay. So the probability would be what? 26 over 1,000. That's 0.026, which is much, much smaller than 0.1586 that Patrick had calculated before, right? Everybody clear? Now, this is just, this is just a calculation from the simulation, but on the test, we won't be able to do simulation and all that much. So fortunately, there is a procedure to do this. All right? Everybody clear? That is, we know that how do these, how does distribution of sample means vary, all right, for simple random samples of any given size if we are just taking samples from a very large population, okay? Everybody good? So let's just go ahead and see what is the mean of these guys, okay? So here, mean of who? Notice this, I'm now computing the mean of who? The means. Everybody clear? So the mean, I'll go up to 1,001. So what's the mean of the means then? It's about 5.2, isn't it? Do you disagree? Right? So this is what? This is the mean of the means. Everybody heard me on this? Okay. Now let's compute the standard deviation of these means. Okay, standard deviation of these samples. I want the same thing. So let's see this here. So we want to go to 1,001, right? So what that comes out to be? Yeah, help. 0.1, right? If we round to 2 digits after the decimal sign, the mean of the means is 5.2, right? Makes sense? And the standard deviation of the way the means are changing is how much? 0.1. Very nice. Thanks. Everybody clear? Okay. So what we just did was this, excuse me, that let me enlarge it a little. So come on. So we saw from a simulation of, okay, samples of size 4, okay, that the mean of the sample means, okay, how do you denote the mean of a sample? I think your book uses this symbol, am I right? X bar is the symbol for mean of a sample if the population, the variable in the population is being denoted by what? X, right? Everybody clear? Okay. So sample means X bar is, oops, not you, come on, is about, if we rounded it to 2 digits after the decimal sign, it's about how much? 5 ml. And that their standard deviation is how much?
0.2.
Let's see. Let's go back there. What was the standard deviation that we saw in the sample? See this here? 0.01. No, 0.1. You're right. Now this time I'm wrong. Okay. So okay, is 0.1, right? Everybody fine on this? So what do you notice? We notice this, that the mean stayed the what? Same, but the standard deviation became what? Less, because the means of the sample will be more consistent towards the mean of the population. Everybody clear on this? Am I making sense? Okay, good. So here is the rule that you shall use, and pay a good attention from this time, because okay, so we have this: if a population, okay, is distributed with what? Mean of, does anybody remember a typical symbol? Well, tell me the symbol that your book uses for the population mean. Isn't that mu, right? Everybody familiar with the symbol? Okay, mu. And what is standard deviation? Say sigma, right? All right. And we take simple random samples of size n from this population, then the means, okay, who are, and for the means we have a notation right here, sample means, and again we are assuming that this letter is x, okay, so then the means x bar of the samples, okay, have mean how much? The same. Remember, you saw it stayed the same, right? And for standard deviation, I'm not doing derivation. I'm just telling you the rule that you can come up with. The standard deviation is given by sigma, the population standard deviation, right? Divided by who? The square root of n. Okay. So in the case of these bottles, what was the population standard deviation? Does anybody, yes, please? What is the standard deviation of the population? Tell me. 0.2. It says 0.2 is like, that's a typo. 0.2, right? 2 is a typo there. So sigma is, or the standard deviation of the population is 0.2. And what is our sample size here? What is the sample size? That's a 4, right? So I'll write a square root of 4, and that is how much? 0.1, isn't it, right? Everybody clear? Now, here is another rule. If the population, okay, has a normal distribution, then the sample means also have what? A normal distribution. Everybody clear? Makes sense? So, say I asked you the same question again on the test, all right? Or Dr. Zhao asks it to you from the test, on the test, then, excuse me, then how would we do it? By using this rule. Okay, let's look at that. All right. Everybody clear? This is what we have to find. So you know this. That is, we just saw our rule that x bar has what? Has a normal distribution with mean how many? Help. With mean of how much? 5.2 ml, right? And standard deviation of how much? Help. 0.1. Very nice. Thanks so much. Okay, 0.1, right? And I'm just stressing it again so that you can keep it in mind, right? ml, right? Everybody clear? So, and we have to find the probability that the mean will be less than 5, and we will be done in a few seconds. Let me bring the picture from the, here is our graph, right? Okay, so there we go. So let's look at our graph. So if I had, say, done this, that is, say, I am doing this. So notice this in here, if I am doing it according to that, and I'm going to do this. Let me just color code it in a different color. How, I don't know how the screen is going to show it. But notice this, see this here? Now you can see this is the distribution of sample means, and it's like narrower, right? Everybody clear? Less dispersed than the population mean, right? Everybody good? Okay, so here. So let me take it to so one moment, let me save this one because I will send a transcript of it to Dr. Zhao. Okay. Okay, so sorry. Good. Okay. So now we have this here, right? Everybody clear? And in this case, what we have to do, we have to find the area under the blue curve to the left of 5, right? Everybody fine? Okay, so let's quickly find it. Okay, so if we went to this, normal CDF was the lower number, please. Somebody, anybody? Okay, we can put 0, right? Okay, now let's go see if we go, say, extra theoretically. Let me put 0. I don't know why I'm trying to do this. I'll put that number in a different context soon. Okay, so and then what I have 5, right? Then I got what? 5.2. Okay, and then what I have, what should I write here? The only difference comes up here. What do I write? 0.1, right? Makes sense? And that is what we saw. We saw about 26 in the simulation, right? Like 0.026. Remember that? Okay, and here is 0.023. So theoretically, this is what will happen. All right, and notice one thing in mind, that in this case, you know that the contents of bottles will not be less than 0, right? Okay. All right, but sometimes we may be in a situation where the values will go negative, right? Everybody clear? So for instance, a return on certain kinds of stocks, they may go negative. Temperature may go negative, right? So see this, even if you had, say, entered, okay, negative 10 to the 99, and then 5, and then 5.2, and then 0.1, you will get the same answer. All right, everybody clear? Why? Because, you know, there's negligible area to the left of that, but theoretically, I mean, this axis is just asymptotically going to the left along with that curve. Okay, everybody fine on this? Now a question is, what do we do if the population does not have a normal distribution, right? Okay, everybody clear? So that's what we will take up. What? Take up. Okay, now is this a normal distribution? It's not, right? Everybody clear? So, I mean, it's like skewed to the which way? Right? Okay. Now, I mean, I could have taken another one, but this one was handy and we are short of time, so I'm taking this one. All right. It is called a chi-square distribution. You will see it in a few weeks in this course. All right. Everybody clear? Okay. Chi is square. Yeah, CHI, and and in letter it's like that capital Greek letter chi. All right. Good. So I am going to do this. That I am going to simulate, like say samples of size. Let's say we are going to simulate samples of size, say 30. All right, from this chi-square distribution, and see how their distribution look like. Right? Okay, so I'm going to do this. Okay, so here you go. Come on, please. Okay. So we go stat, all right, and calc. We want random data, right? Okay, here is chi-square, and let's look at let's look at 1,000 samples, right? And our sample size is going to be 30, right? That's what we chose, right? Okay, and what we have. So we have 1,000 samples of size, how much each? 30 each, right? Now what I'm going to do is that I'm going to put the sample means in here, exactly the way I did you saw it in that Excel sheet, right? So I will very quickly calculate the mean, right? And the thing is, input variables are C1 through C30, right? Everybody clear? And so these are all the sample means. Everybody clear? Okay. Let's look at, let's see how they look like if we looked at a graph, all right? This is a simple histogram, right? We want that of C31, right? Okay. Is that badly skewed? No, right? Let's increase the sample size further, okay? So we will do this, calc, random data. Say, for instance, instead of 30, we got 50 this time. Let me close this histogram. Oh, just a second, I'll close this histogram. We saw whatever it looked like, and then go back. Sorry about that. Okay, and we are about done. I have 2 minutes, so be patient, okay? All right, okay. So number of rows, we'll still keep it 1,000, right? Okay, so we got C1 through. I'm increasing the sample size, right? And I see, in a hurry, I'm getting nervous, right? Okay, random data, chi-square. Good. Oh, very good. Now it's much easier now, right? 40. So we got that. Okay, it did this. It took everybody through there, right? Okay, and here. Did I say C1 through C40 or no? I did. So why did
the 31 for the mean?
Okay, I see. This is like, this is from the, is this from the same place? That I think it is. Just a moment. Let me just quickly see that it overwrote the data in 31 or not. So what will be a good way to do that? This, and I still see. Yes, it did bring, see, column 31 is from that, that skewed portion, right? Okay, good. All right. Okay, and I have 1 minute remaining. Okay, so I better finish fast, right? Okay, so if I look at the sample means, calculate row statistics, right? This time I have what? I'll go from this to who? 41, right? Here they are, and then there you go here, and this time instead of 31, who will I take? 41. That's it. I mean, it has just one slight thing here. So you go on increasing sample size. What the distribution of samples means will do? They will show approximately a normal distribution, right? Larger the sample size is, okay, more normal, if I want to say that in plain words, more bell-shaped or whatever the distribution of sample means will look. All right, thanks so much for staying. All right, nice to meet you all.